Episode 6 of Bucket Questions. Let's see what we've got today. Today's question is, are farts a type of radiation? I really like this question. I love questions where people are wondering about everyday things such as their own bodies. Well, let's try to figure out what the heck a fart is. This is going to be awesome. To understand radiation, first we're going to take a look at understanding how scientists classify everything in the universe. Scientists love to put things into the categories, and one of the things that they want to categorize is all of the things in the universe. And scientists have basically separated everything in the universe into either matter, or energy. And how can now scientists go on and classify matter and energy? So now you have two big categories. How can we make them even more categories? Well, it depends on what kind of scientist you are. If you are interested in physics and engineering, then you might choose to categorize your energy in terms of its definition as the ability to do work. And if your energy is defined as the ability to do work, you're going to probably categorize it as kinetic or as potential. And maybe you remember this from Mrs. Simon's class, but kinetic energy can be defined as the energy of motion. And that is going to include things like mechanical energy, driving turbines or pushing pistons, as well as sound energy, because sound comes from the movement of particles through the air. Whoops, wrong one. There we go. Light energy, which is because light travels as a wave. And heat counts as kinetic energy because heat is generated by the movement of particles, and the more they move, the hotter something is. Potential energy is going to be the energy of position or stored energy. And some of that energy includes things like the energy of gravity. If something is up high and you drop it, that's got gravitational potential energy. The energy of elastics or springs. The energy that is also considered chemical energy, which is a kind of stored energy. And chemical energy is the kind of energy that is in batteries. I can spell, try one more time. There we go. And the energy that is also contained in our food. But if you're not in physics or engineering, if you're a biologist or an earth scientist, it may be more interesting to categorize energy in terms of what we call the electromagnetic spectrum. So let's take a look at the electromagnetic spectrum. Oh, yeah, I forgot. Joke. You matter. Either matter or energy, right? So you matter until you multiply yourself by the speed of light squared, then you energy. It's so funny that I got the t-shirt. Okay, so now we're going to take a look at the electromagnetic spectrum. And this is most of the energy in the universe, and it travels in waves. And the difference between one kind of energy on the electromagnetic spectrum and another kind of energy is really everything to do with the actual wavelengths, the distance from one wave to another wave. The shorter the wavelength, the higher the energy. The longer the wavelengths, the lower the energy. But most of the energy that is contained in our universe can fit on this spectrum somewhere. You can see radio waves, infrared, that means heat, ultraviolet, gamma rays, X-rays, and the visible light spectrum, which is really only this teeny tiny section of the electromagnetic spectrum. So let's go back to our chart here, and we can start to put on some of these things. We can put radio waves, heat/infrared, visible light, ultraviolet, X-rays, and gamma rays, which is, whoops, too many N's, which is what we think of as nuclear radiation. And all of these things are energy. So, we answered the question of what is a fart? Well, is a fart energy? Is it heat? Is it light? Is it sound? Well, maybe. You ever do the thing with a balloon where you kind of do this? And it makes a bunch of noise? Well, farts do that sometimes, don't they? But in order for the noise to be made, what we have to do is pass air particles through the opening of our balloon in a tight space. And so when we're making sound, where that sound really does come from is that it comes from the air. So we know that if the balloon makes a sound and that comes from air pushing through the opening, then our fart's air. What's a better word for air? Well, gas. And you guys know perfectly well that farts are probably quite likely gas because that's actually a synonym for farts. And labeling something as a gas is one of the ways that we can, in fact, talk about matter. There we go. And so one of the ways to classify matter is based on the states of matter, which we can consider to be solid, whoops, wrong one, there we go, liquid, gas, plasma, and a handful of other ones that really only apply to science nerds. And so if we know that farts are gas, then they're likely matter. There are other ways to think about matter, and chemists usually like to think about matter in terms of the atoms that matter is made out of. And so if something is made out of atoms, it can be an element, and an element, or elements are going to be anything that has its own box on the periodic table. And so an element really can be thought of as just one kind of atom. And if you look on periodic table, there are some examples, and they all have abbreviations. Some that you might know of are oxygen, helium, neon, gold, iron, etc. Things like that are considered to be elements. But not all atoms are arranged in elemental form. Some of them are compounds. And a compound is going to be two or more elements that are chemically combined. And examples of compounds are going to include things like salt, sugar, diesel, proteins, sand counts, etc. Those are some common compounds that you might see in your everyday life. And there is even more. Sometimes things are mixtures and not compounds. And mixtures are going to be two or more substances that are physically combined. And so it could, by substance, a substance could be atoms, it could be elements, it could be compounds, but they're mixed together instead. And so things like that are going to include steel, which is a mixture of iron and carbon. Wood, whoops, wrong one, here we go. No. Delete that. There we go. Okay, wood. Most of the things that make up our food and drink are going to be mixtures. Most cloths and other textiles, rocks and minerals, and the air that is in the room and the atmosphere, those are also going to be mixtures of atoms or elements or compounds. Okay, so where do farts fit into all this? Well, we've already decided that they were gas, which in this case is therefore going to mean that farts are going to be therefore made of matter. And if it's made of matter, then farts are not energy. And if radiation was in our energy category, then that means that farts are not radiation. They are made of matter. What kind of matter? Well, One of the things I wanted to point out is that we sometimes farts smell. That smell has to be a gas. The way we smell is that we have gas molecules of particular kinds of gases that have evaporated up into the air, and then we breathe them in through our nose, and they get sensed by our smell receptors. And so therefore a smell is really, oops, wrong color, is really a chemical. And if it's a chemical, that means it's going to be made of atoms. So yet more evidence that farts are not radiation, they're actually matter. The elements that most farts have to be made out of are this one here, carbon, and this one here, hydrogen. And they are combined in a form that makes the gas methane. We've got a carbon surrounded by 4 hydrogens, and its chemical formula is CH4. So therefore it's made out of elements, and it is matter. So your farts matter. But you know what? They're not really your farts. They're your bacteria's farts. Everybody has lots of different species of bacteria that live in their intestines, and they help us break down our food and make poop. And it's actually the metabolism of the bacteria that create farts. So somebody accuses you of having really bad gas, don't blame you, blame your gut bacteria. Our next question comes from a middle schooler who's been researching mummification, and they found a thing that says that the Egyptians used a thing called natron salt. What the heck is natron salt, and how is it different from regular table salt? Well, the answer comes in the scientific definition of the word salt. When science talks about, well, table salt is just one thing. Table salt has the scientific name of sodium chloride. Try that C again. And so it's made of 1 sodium atom and 1 chlorine atom stuck together to make a compound. And that's what we think of as salt, but scientists define salt a little bit differently. Salt is made by a particular kind of bonding, and bonding is done by atoms. So if we draw a generic structure of an atom, here's our nucleus. We're going to have some electrons circling around it. Let me make a few. And it's these electrons on the outside of the atom that are responsible for having chemical reactions and making compounds through the process of bonding. And you'll do a heck of a lot more of that with me when you have science classes. The way that atoms bond is partially determined by their position on the periodic table. Everything on this side of the periodic table has very few electrons in its outer level. These electrons get easily lost, and these elements are going to turn positive. Elements over on this side of the periodic table, they have many valence electrons in their outer shell. These guys tend to steal electrons, and all of these elements over here tend to turn negative. Now you guys know what happens when we've got a positive and a negative together. They attract. Atoms work just like a magnet. The elements over here are literally magnetically attracted to the elements over here. And the biggest example of this that we're most familiar with is sodium being attracted to chlorine, which is negative, and that's table salt. But science defines salt as anything from the first 2 columns that are going to turn positive with pretty much anything from column number 17 that turns negative. So when these elements here chemically combine with these elements here, that's the definition of a salt as far as chemistry goes. And so this natron salt is a combination of different kinds of salts, and what they all have in common is that they all start with sodium, and that's where the word natron comes from. So natron salt is a mixture of different kinds of salts of different combinations of elements. For more information on mummification, you can visit my favorite nerdy chemistry website, Compound Chem. Hope you enjoyed this presentation. Have a great day.